So now we have Pablo with us. Please welcome Pablo.
Thank you. Well, as a disclaimer, I prepared something like 30 slides, but I usually go really fast. So I don't know if I'm going to use the 50 minutes, but let's see. OK, so who am I? So I started coding at the age of 9 on a Commodore VIC-20. Who was a C64 generation from here? It's fair enough, fair enough. Yeah, I have over 35 years of software development and architecture experience. I'm currently chief architect at Entity Data. There is a very big IT consulting company. In the future, I probably will continue to code, right? I plan to retire coding, but maybe side by side with an AI, right? And I want to explain why I say this. So most of us programmers, we play chess or know how to play chess. After Kasparov lost the match with Deep Blue from IBM, he pushed the next level of chess on something called advanced chess. But it's also called Centaur chess because it's a combination of a human and an artificial intelligence. So you can actually play games in this modality. And I think it will be probably the near future of most of the things that we do as programmers, developers, and architects. So we all have been there in 2015 when Sam Newman announced there would be the year of microservices. And we were all doing monolithic apps and moving to microservices, and we were on the hype, and we were testing, and we were breaking things and rolling back to monolithic. That path is actually being repeated right now, because everybody's telling that 2024 will be the year of the AI agents, right? From monolithic models to compound systems. Yeah, I find this very, very insightful. These are I found this on a website that was talking about the enterprise AI adoption stages. The first stage is the prompt-based AI, so generative AI on the lower level, meaning that you can interact with a model using something like ChatGPT or some other cloud provider system like Azure, OpenAI, Amazon Bedrock, Google Gemini, or even looking to work with local deployed LLMs. How many people here have deployed locally on their computer LLMs for playing? OK, that's very good because it's very important to own your own AI, because if not, you're just using somebody else's data, and it's maybe not aligned with what you need. The second layer, it's called Contextualized AI. These are RAG systems. Maybe in previous talks, there was this concept mentioned. I will dig a little bit on it a little bit later. But it's mainly a combination of searching documents for specific keywords or queries, and then augmented the answer with the help of LLMs. And then on the third stage, there is something called AI agents, which is actually just the next level of hyperautomation. And I will go through that in a bit. So prompt-based AI. So I always, when I talk to students, I always make this comparison of, well, everybody learned how to do math properly before using calculators. With AI prompt systems is actually more or less the same. We all learn how to code, logic, etc. And then we accelerate by using prompt-based AI, right? It's not something that we are very surprised of, because they are just trained with a lot of code available on the internet. But it looks like a little bit of magic. The first time you interact with this prompt-based AI, it looks really, really cool. But they have a problem. There is a limited knowledge available, because they are trained, even if they are trained with huge amounts of data, they have boundaries in time and space, right? So probably if you use GPT 4.0, it will be trained with data just from maybe last year. And the amount of data available on the internet is finite, so it's not, it cannot be expanded forever. So a lot of these prompt-based AI systems are being started to be trained, instead of with natural data, with synthetic data, because there is not enough data on the internet to fuel these very large models that are called frontier models, actually. And they are hard to adapt. Fine-tuning a model, or even creating one from scratch, requires enormous amount of data and resources. You've heard that, there are data centers of 100,000 H100 NVIDIAs out there, just training models that consumes a lot of energy. And most of us, we cannot even afford to have an NVIDIA RTX locally on our PC. By the way, I actually stole my kids' RTX to play around a little bit. And I recommend, if you have kids that have NVIDIA playing games, just get them borrowed. So for prompt engineering, there is a lot of techniques, right, that are being used. The one that I want to talk about later is the chain of thought, right? Because this is actually how humans think. We have some steps that we use, and sometimes we even verbalize these steps to explain to ourselves how are we doing reasoning. Of course, sequential prompting is very important, and the REACT pattern is something that we will explain later. Let's talk about reason and act. So the second level talks about contextualized AI. It can do more complex tasks, right? We can add context to the model. So some people get confused because they say, okay, I need to retrain the model, and that's actually not possible. You can add context to the model, right? You can use a RAG system to create embeddings over vector databases. You can ingest fresh data to be used, and you can interact with your documentation. And this is a very, very clear use case for enterprise big companies, because they have a lot of documentation that is not available on the internet, and it's very hard for them to use this information properly. If you deploy a RAG system, so retrieval augmented generation system, you can actually ask questions to the documentation in natural language, and again, magically you will have probably the right answer, or at least where the data lives for you to look for. So this is a typical RAG system that there is a question, you interact with the knowledge base to get the relevant knowledge that could answer the question that you submitted, and you send the question plus the relevant knowledge to the LLM for augmented generation, right? And the answer is not just where the relevant knowledge is, but is actually a phrase or a text that you can actually understand and continue to use in future requests. So, when designing generative AI and agentic systems, there is a need for return to the system design basic concepts. Maybe this slide was also shown here, and every single architecture meeting. But we are all familiar with the concept of separation of concerns, encapsulation, abstraction, loosely coupling, high cohesion, scalability, performance, resilience, fault tolerance, security, and privacy. All of these concepts, again, reapplies to agents. So AI agents, they can do even more complex tasks. There was one example that I was looking into to describe how agents can actually do their job. Imagine that you want to go on holidays, on vacations, right? And then you ask your LLM to tell you how many days of available holidays I have. Of course, the LLM is just trained with some data that is not relevant to you. And they can, by themselves, they cannot access the holidays database that has this information. If you add on top of that a RAG system that can access your knowledge base, creates the embeddings on a vector database, and you can point to the data, you could actually ask this holidays database, okay, how many days I have left of holidays? And that will be an answer that will be accurate, that could be actually retrieved in a very efficient way. But imagine that you ask, okay, I want to know how many days of holidays I have, and I probably will go to a place that has a lot of sun, for example, Barcelona, and then you want to ask some specific questions that are not related to your holidays database, right? For example, weather. In that case, there is a need for deploying a more complex system or a compound system that has specific tools, right, that are used by the agents to fetch the data from the right places. And it could be a combination of deterministic and non-deterministic components. Deterministic components are the microservices that we created in the past, right? It's always the same input, will have the same output. On a non-deterministic component, whenever you interact with an LLM, for the same request, you will have probably different outputs, right? And we need to be able to manage those outputs and understand, using feedback loops, how to actually get more accuracy. There is this concept of hallucination as well. So whenever if you interacted with some frontier models from the past, like GPT 3.5 or 3.0, there was a lot of hallucinations there. They just invent things. It's like a black box, actually. We don't really know how they are coming to the answer. But yeah, the reasoning started to be surfaced, right? Which is the most important thing on an LLM. And then the control logic of a program can be represented as workflows. The AI agent's capabilities can be summarized, and they can reason, right? They can explain why they took some decisions, and they can act over tools, right? Azure calls them plugins. Every cloud calls them how they want. And then they also have memory access. So they have this concept of context that can be retrieved whenever it's needed, and you can even ask for past iterations to get more context to be available. So agentic workflows, they represent workflows that we are familiar with, right? Everybody works with state machines. That's the most common one, but there are directed acyclic graphs and control flow graphs. This is something that from system designer workflows we have been working a lot. And these are now being applied to perform certain tasks, right? In this example, there was a query task sent to an agentic system that first they will probably split the task into smaller parts to be able to perform that more efficiently. Frontier models that are trained with a lot of data, you can ask GPT-4 to perform a very complex task, right? But that, again, is requiring a lot of resources, and maybe splitting the problem into smaller parts. This is how we actually program systems. Maybe it's a better solution for the queries that are being sent. So the system has also memory and has access to tools to act. And then they do something called observation. They observe the output, and they compare this with the task that was required. If the output is not exactly as it should, it could return with a feedback loop to the plan and thinking and say, okay, maybe this plan is not the best one, and I need to iterate again. Okay. There are agents conversational patterns. This is coming from Microsoft, that you can actually have agent customization with a conversational agent. You can actually tell the agent what you want. There is multi-agent conversations, right? That agents interact between each other to perform a task. And there are some other conversational patterns that are probably implemented mostly on chatbots. There is this concept of robotic versus agentic process automation. And robotic process automation is what we have been doing until now with the standard workflows, right? With the same input, we will have always the same rigid task being done. For this robotic process automation, the problem is that programming every single case of the input that you expect the output to be there will probably create a very, very large workflow with a lot of if-else conditions that will make this hard to understand. They will be not as efficient, but at the end, they will do the task, right? On agentic process automation, you actually ask an agent to take control of the workflow, okay? And then the workflow will start to be auto-generated and created based on the inputs and the task that was assigned. Why this is so powerful is because the LLM's capacity to understand natural language allows a human to monitor and interact with the system in a very dynamic way. It's not everything is programmed and then it just does the job, but you can actually provide feedback. Right? In the hyperautomation scenario, agents will talk to agents, and they will create their own workflows. And the human interaction over time will actually decrease, right? We don't know up to what level, because this last mile of work that needs to be done will always be there, in my opinion, for the work that the agents will do. But eventually, it could go to a minimum interaction from humans. So this is a maturity model that we have been implementing in most systems that were built over the last, 10 years. It applies perfectly to microservices, and I believe it also should apply for agentic AI. So decoupling is important because it allows fast iterations, and it doesn't require all the contracts, they say, to be set up at the beginning of the interaction. You can actually just find a communication schema, like an event-driven architecture with some event streams to actually enable decoupling. And automation here, it's more in the context of monitoring, right? And I will explain later a bit how monitoring needs to be applied on Agentic AI. Well, this is coming also from microservices. Orchestration and choreography, these are two patterns for sync and communication. Whenever you see service here, it can be replaced by the word agent. In an orchestration, there is a central system that takes care of actually executing the workflow in a specific order. But it's true that it creates a lot of coupling between all the services and agents. On a choreography pattern, there is more decoupling. Service interact with each other through a communication bus. It's just an event stream. So it could be Kafka, maybe, on on-prem, Azure Event Hubs, Amazon Kinesis, you name it. And what happens is that each service is listening, or agent is listening to a specific topic that could be the output of a previous interaction with another agent. Right now, on the company that I'm working with, I'm taking care of app modernization, right? And what we usually do is we receive very old legacy code, right? COBOL, even web forms, ASP, Java 1.8, etc. That this application needs to be modernized, and we define the as-is architecture and the to-be architecture. And in order to modernize a very large code base and legacy code bases, that most of the programmers that work there are not even anymore in the company, but the system works, right? We deploy a series of agents that are actually looking into the code base from different angles, some different roles, and I will dig into that a little bit later. So I could deploy an agent that is specialized on documentation, right? Just reading the legacy code base, they could start writing some of the documentation, explaining what the code is doing, because there is probably not a lot of documentation available. It could also extract the use cases that are actually implemented by analyzing the code. Then there could be some product-oriented agent that could look into these use cases and decide if these use cases need to be migrated to the to-be architecture. There could be even a multimodal agent that could look into the screens that were on the legacy system and decide which would be the best UX improvements that could be there. Then there will be a front-end agent that is specialized on a particular framework, I don't know, like Vue.js. And then there will be a backend system that will be specialized in Spring Boot and Java 20. And there will be also an agent that is specialized on testing, right? Created the test cases, or even writing some, together with the product agent, some Gherkin's language to be understood later. And then these agents, maybe there will be one taking care of the CI/CD pipelines, right? And they can actually automate that and deploy it into some other systems based on the use of tools. Every single agent that will participate in this code migration will produce events that will be sent to the event bus to be consumed by the next agent to continue to do the work. And then you can repeat this feedback loop as many times as needed in order to adjust the prompts. So this is actually happening for people like me that I don't understand COBOL. but I do understand it to be architecture, to be supported by the use of agents into this migration. Of course, we need to look at the deployment pipelines, how these agents are needed to be deployed. CI/CD needs to be there, and automation. When we built microservices and we created containers out of it, most of these microservices were stateless. But in the case of Agentic AI, there is a component and a state that is actually injected in runtime. So when you interact with a chat-based system, there are different roles. Right? You have a system role, you have an assistant role, or a user role. When we create and deploy an agent, they will have an LLM that is actually baking this reasoning capacity. But you can inject a system role saying, okay, you have experience in testing with Java 20. And then you can feed the agent with some more context. This happens in runtime. It doesn't happen on build time. Concepts of observability and monitoring are key for these systems not to get really out of control. And also, governance and accountability needs to be put in place. Accountability because agents could make mistakes, right? They will have some guardrails to actually control what they are doing, but someone needs to be responsible for the actions that they perform. If you connect the agent with a plugin that could create a pull request in GitHub, that's fine, because someone will approve that pull request and make the code review. If you connect the agent directly with an agent that can deploy code to production and self-approve the PRs, well, you need to have a little bit more accountability on that. But everything is about the level of automation that you want to put into the system. So we will talk about some patterns that are being implemented for these specific systems. There is this, the most common one is the React pattern. It has nothing to do with the React framework from JavaScript. It comes from the words of reasoning and act. In this example, we are using OpenAI model GPT-4, right? And we are just deploying a React agent to interact. And then we asked the chat system to go through a mathematical operation, right? What is 2 plus 2 multiplied by 4? And then there is some steps that the system is taking, right? Probably some deterministic tools, right? Just a calculator would do this work much better. But sometimes for reasoning, you need to make some mathematical basic operations. So that's why this example is very clear for the chain of thought approach. Okay? So it reasons that it will need to use some tools to have the answer to the question. It knows the order of the operations that need to be executed, and it calls the action multiply. Okay? With a specific input, and it gets the observation that is the first response, 8. Then, now that they have the result of multiplication, they will need to add this result to 2, and they call the action add. Probably this action is calling a tool that is actually just a calculator. And the next response is the observation 10, and then it will compound the two, summarize the two answers for a final answer. This is related also to the workflow that I showed before. So the React pattern, it has a thought process, an act, and an observation process. The task planner pattern, right, could be dividing that into just the steps that are being needed to do. It has a little bit of coincidence with the React pattern, but this is just dividing the task into steps. And the multi-agent orchestration, there will be an orchestration agent that could be also a choreographer agent, right? That could work with some events. There will be a routing of the tasks to the different agents. That again, if it's a choreography pattern, it will just listen to specific topics. And there will be an agent catalog that the orchestrator or the choreographer is aware of, right? These are, for example, on a modernization example that I explained, there is actually some catalog of agents that could do the job, right? The catalog is actually created by injecting in runtime the system prompt to the agent. Okay, let's talk about some agent frameworks that I recommend you to, if you are interested in all this space that is popping up, maybe it's time to go back to coding and start playing with those. Llama Index is a very powerful framework. All of these examples are actually Python examples because the libraries are much bigger than the other languages. But you can do this with Rust, Java, Go, even JavaScript to play around. But usually when I dived into these frameworks, I go through the use of Python 3. Then there is some frameworks from the big cloud providers. From Microsoft, you can have Autogen. There is a very easy framework to deploy. Well, the image here is from OpenAI Swarm, but yeah, the link for the GitHub is correct. Then OpenAI released 4 days ago Swarm that resembles some of the Docker things that we worked in the past. And it's actually something that I didn't try yet, but it's very lightweight from what I've seen. And the examples that are there on GitHub, on the README, are very clear. So I recommend you to take a look into that. OK, then from Amazon, we have this multi-agent orchestrator that is a very centralized system that takes care of executing the workflow in a specific order. And then some of the tech stack that I recommend people to work with. Python, of course. Qdrant is a vector database that is very also lightweight, everything that you can deploy with Docker as well. And if you want to create your first RAG system, that is actually, if you work on a company that has some documentation that you don't want to send maybe to a cloud provider, maybe trying out Qdrant could be a nice solution. Okay. Oyama is it's actually a model management system that gets the open models from Hugging Face. How many of you know Hugging Face or have played a little bit with the models there? You have models, multi-models approaches, text to text, image to text, text to image, etc. Why text to image is important? Because us architects probably need to or are using diagrams as code, right? The same way that we have infrastructure as code, there is something called diagrams as code. There are Python libraries that you can actually define by code some of the of the architectural schemas that you want to print out. And we use those actually to extract information from software definitions and just paint them on diagrams. There are some specific embedding models in Hugging Face that you can use to actually play around with that. And yeah, that's it. I don't know if I managed to do it in the right timing. Thank you, everybody.
Thank you, Pablo. Perfect. I think that it will be better if you answer it from there, so people can actually see you. This is Pablo. We have many questions, Pablo, for you. And the very first one, the most voted one, is what's the underlying architecture guidelines on agentic implementation? Could you share a reference architecture used in a real product environment?
Yes, I think I mentioned some of those in the presentation. Right now, I'm mostly using a communication pattern that is choreography for the agents to be deployed. We deploy the agents on containers, probably on Kubernetes. These containers have access to LLMs somehow to make requests. If you deploy those on Azure AKS, you can use Azure OpenAI. Depending on the cloud, you use Amazon Bedrock, etc. But mostly it's containers and probably Dockers deployed over Kubernetes on-prem. If you want to do that on-prem, probably on OpenShift. And then you use the models. The engine, the LLM engine, is actually some of the models that are available on the cloud providers. I don't like a lot OpenAI GPT-4, which is a very good frontier model, but I prefer European models. So we have Mistral AI from France that is very, very powerful, and it's open, right? We have also Llama 3 from Meta. Cloud from Anthropic is a closed model, but it's also being used a lot. And yeah, we use Kafka or some other event streams for the communications.
Thank you. We have a philosophical question here. We have calculators, but it didn't defeat the purpose of learning math. We still learn math, and we still learn multiplication tables, probably for a good enough reason. But how about software development? Do you think abstracting from it even further and delegating the knowledge base or learning job to AI is a really good idea?
Yeah, of course. As I mentioned, I probably will end my life coding. But I look at the example of my kids, right? I have 4 kids, and 2 of those are already starting to learn coding. And they also have ChatGPT just side by side. I do recommend understanding coding and continue to learn how to program and how to design systems, because the tooling that we are using were actually designed by programmers, right? And the calculators were also designed by engineers, so that will not change. For me, it's key to continue to learn programming. Of course, this will evolve to a place that we don't still know. Yeah, and the technology, it's always evolving, and I'm not coding the same way that I did when I was doing assembler on microcontrollers, right? But yeah, the basic concepts of math are still there, and physics for electronics as well. That will not change. Well, quantum computing could change everything, right? But we are not yet there. Maybe next year we can talk about quantum computing.
Would be great. Thank you. Yesterday we saw many examples that clearly confirm that LLMs cannot reason, although they are good at bluffing it. You seem to take for granted that they can reason, even though there is nothing in their architecture that supports reasoning. You use the word like magic. Please explain this discrepancy.
Yeah, I agree. It's not actually reasoning, but because you can deploy feedback loops, right? You can actually feed the output again to the input in order to have recurring steps to be executed, right? Until the output comes in the form that we expect. It's pseudo reasoning, of course. They don't have ability to reason, but we don't even know how they get the answers, right? That's the magical part, and everybody in the industry is talking about this, surfacing how they actually reason. So Anthropic with cloud is trying to do that very hard, because if they don't understand how they are reasoning in the form of feedback loops that are providing answers until you get to a point you want to go, it's very hard to try to achieve this artificial general intelligence that everybody is looking into, right? For me, it's not anywhere near, but we're moving really fast. From last year to this year, it was just crazy what everything is popping up. So I think it's our duty to actually catch up as much as possible. We cannot be surpassed by this hype or trend. The same way that we adopted microservices patterns for solving specific problems, we should adopt agentic patterns for solving some of the system problems that are being taken.
Thank you. You were presenting an example on downloading the most important papers. How an agent can understand what are the most important papers? What kind of definitions we should make to make an AI understand paper quality?
I think it's about embedding and using vector databases to actually create numerical matrices to actually find the data. It's not about the most relevant ones, but all the content that is ingested and the embeddings are created, you can actually find the most similar wordings there. Of course, you can use several types of LLMs, right? We are talking about generative AI LLMs that are specialized on finding the data specific there and then predicting the next words in order to complete a phrase. I think it's about, it's not the most important papers, but actually the ones that have the most similar data that will enter the prediction path that I will be using.
Right, the most relevant ones, probably, yeah. Could you please share, and this would be the last question, could you please share more information on the different agents you are using for the mentioned app modernization?
Yeah, I think the most capable ones are the front-end and back-end agents. They actually perform really well and in whatever language that I throw into them. The problem with this kind of agents is that you cannot throw a complete repo, right? If you have repos with a million rows of lines of code, you need to split those because LLMs, they have something called context windows, right? That usually with the models that I have been using is 32K tokens, right? Tokens, how to calculate the tokens, there's multiple ways to do that. And these systems they kind of behave very deterministic because they have been trained with GitHub and GitLab information from the internet from millions of repos, right? So they probably are trained with very good data, right? You don't usually find bad code in GitHub. Of course, you can find it, but if you select properly the repos, you will have very good output for the systems.
But basically, you build the agents. So there are no agents.
Yeah. So we define the agent system role with very specific prompts. We use in the background the so-called frontier models, right, that are trained with huge amounts of data, but you tell them, okay, but I need you to narrow every single response that you have to give me on a specific type of role. Okay? By narrowing the generic use of the LLMs, you get much more accurate responses. Of course, all the agents are using a model, right, that is actually generic, but the agents, they have a very narrowed response spectrum that allows you to actually interact with them more efficiently.
Thank you. This was the last question. Thank you. Thank you a lot, Pablo.